So before we do the questions where we combine everything that we've learned so far, there's two more things we need to talk about, and that is the domain. And the domain, these are the x values of the function. And specifically, these can't be the vertical asymptote or the removable discontinuities, or the holes. So any vertical asymptotes and any holes in the graph, you got to make sure that you remove these from the domain because the function is not defined at these spots. As well as sometimes our graph can cross the horizontal asymptote. This is kind of interesting because the asymptotes are really boundaries in the function. Vertical asymptotes will never be crossed, but sometimes horizontal asymptotes can be. It's always in the short term, meaning as you go out to infinity and as you go out to negative infinity, they won't be crossed. But when it's kind of more local, it could be crossed. And then as you continue out towards infinity and negative infinity, it will approach it, but not actually reach it. So sometimes the graph crosses the horizontal asymptote. To find out if it does, what we need to do is we need to set the function equal to the horizontal asymptote and solve for x. Okay, so these questions are like the main event, if you will, of this section. These are combining everything that we've done. And again, this is getting you ready for calculus because not only will calculus ask you these ones, but they will ask you other things as well, other analysis about the graph. So these are all the non-calculus things. So my first step is to factor. So I want to first factor. So if I do that, then I'm going to get x plus 5, x minus 2, and x plus 5, x plus 3. So the x plus 5's cancel, and I have x minus 2 and x plus 3. Okay, so part A, this is talking about the holes. So did something cancel? And the answer is yes, the x plus 5's canceled. So there's going to be a hole at x is equal to negative 5 because it's the 0 of the factor that canceled out. So x is equal to negative 5. Okay, next up is the x-intercepts. So this is part B, which is the x-intercepts. And to do that, I want to set the numerator equal to 0. And I'm actually referring to this version of the function now. So y is equal to x minus 2, y is equal to x minus 2, x plus 3. This is like what I'm going to refer to now, instead of the original. So for the numerator, it's going to be x minus 2 is equal to 0. So if you move the 2 over, you get x is equal to 2. And this will be 2, 0. So 2, 0 is our x-intercept. For the y-intercept, I'm going to set x equal to 0. So y is equal to 0 minus 2 over 0 plus 3. And that's equal to negative 2/3. So this will be 0, negative 2/3. Are we halfway done yet? No. Okay. So next up we are finding the vertical asymptotes. So to do that, I want to set the denominator equal to 0. So this will be x plus 3 is equal to 0. Again, note I'm referring to the new version of the function. So x is going to be equal to negative 3. That is going to be my vertical asymptote. Next up is horizontal asymptote. To do that, I want to compare the degree. So if I'm referring to this one, these have the same degree. So it's going to be the ratio of the leading coefficients. And my leading coefficients here are 1 and 1. So this is going to be y is equal to 1 over 1, or just y is equal to 1. Part F is the domain. And the domain can't be part A, which are the holes, and it can't be part D, which are the vertical asymptotes. So my domain, I want to give it in interval notation, and I want to exclude negative 5 and negative 3, because negative 5 and negative 3 are those values. So this is going to be negative infinity all the way up to negative 5. Start back at negative 5, go all the way to negative 3. Start back up at negative 3, go all the way to infinity. So that is going to be my domain. And then does our graph cross the horizontal asymptote? So for part G, you can call these the alphabet problems because you're doing like half of the alphabet here. For part G, you want to set the function equal to the horizontal asymptote. So that's going to be x minus 2, x plus 3, and I'm setting that equal to the horizontal asymptote, which is 1. I'm going to actually solve this like a proportion. So if you're solving like a proportion, I want to make this look like a fraction. And then I can cross multiply. So x plus 3 times 1 is x plus 3. X minus 2 times 1 is x minus 2. And if you subtract x from both sides, the x's go away. And this 3 is equal to negative 2, which is false. Therefore, it does not cross. So this would be doesn't cross. Okay, so lastly, we want to take all this information and graph the function. So it doesn't need to be perfect. Okay, so I know that the x-intercept is at 2, 0. I know my y-intercept is at 0, negative 2/3. I know there's a vertical asymptote at negative 3. I know there's a horizontal asymptote at 1. And I know my domain is that. I know I don't cross. So if you actually graph this on the calculator, so if you kind of want to get a better idea about what it looks like, you can graph it. And again, make sure to put the parentheses around your numerator and your denominator. And if you do a zoom standard, you can kind of get a better idea about what the graph looks like. So it's going to be like that, and then like that. So the only other thing that I'm missing here is the hole, and that's at negative 5. So over here at negative 5, I want to draw a hole, and let's see if I can erase that inner part. There we go. So that would be our graph. And this is 12 minutes and 45 seconds. So definitely a lot of work. Don't forget to like, comment, and subscribe.